absolute value inequalities, there's two types of them. So you're either looking at absolute value where it's less than, so x plus 4, the absolute value of that is less than 10, or the absolute value of x plus 4 is greater than 10. Let's just take a second and recap absolute value. Absolute value is a distance. It can never be negative. It's a distance from 0. So what we're going to look at here, there's two cases. If you notice, the only thing different between the two is that one, the absolute value is greater than, one, the absolute value is less than. So I'm going to focus on the left side first, and when the absolute value is less than. So the absolute value of x plus 4 is less than 10. I'm saying it has to be either no bigger than 10, but no smaller than negative 10. I'm looking for a small bubble, right? If the absolute value is the distance from 0, and the distance is less than 10, I can either go 10 to the right, or I can go 10 to the left. That tells me my numbers must fall between, you see right here, they must fall between negative 10 and 10. So what I do is I set it up as an and. You want to make a note on the side of your page here. You set it up as an and. And I'm going to sandwich the inequality between the 2 points, and then I drop the absolute value. So notice, if it's less than 10, I sandwich it between 10 and negative 10, and then I drop the absolute value, and I solve the inequality. This is a three-piece inequality, which is why we hit that in compound inequalities. In the end, you end up with your inequality here, which is x is greater than negative 14, but less than 6. An open circle on the 6, a closed circle on negative 14. I'm sorry, open circle on negative 14, and I shade in the middle. So anytime there's a less than, it's an and. If you look on the right side, I have the absolute value of x plus 4 is greater than 10. That means it cannot be within that bubble. So this is why I have this picture here. The absolute value is anything out here, anything greater than 10. So anything with a distance from 0 greater than 10. So it can't be within that bubble with everything on the outside. So how I do this one is I set up an or. So make a note on the side of your paper, you set up an or. And what happens here is I have an or, x plus 4 is greater than 10, or x plus 4 is less than negative 10. So here it must be greater than 10, or it must be less than negative 10. That's where I'm getting these two absolute values from, or these two inequalities from. I make the one, I keep the plane, I drop the absolute value, and I solve it. So drop absolute value and solve as normal. And that's this one right here. It looks just like my original, just no absolute value. And then the second one, I make the other one negative, and I flip the sign, because I'm talking about everything smaller than negative 10. Once I have those two, I solve them both separately, and I end up with x is greater than 6, or x is less than negative 14, and I have an or inequality. I just want to say, when you're doing this, the absolute value needs to be isolated. Notice it's the absolute value by itself on one side, absolute value by itself on the other side. If you had something like this, absolute value of x plus 4 is greater than 12, but I had a 2 on this side, I would need to get rid of the 2 first before I started. So just to note, absolute value must be isolated. So you isolate the absolute value before you begin. I'm going to do two examples with you, one where it's a less than, one where it's a greater than. So I'm going to start with number 1. I have this absolute value of n divided by 4 is less than or equal to 3. That tells me my distance must be no more than a radius of 3. So that gets me to 3 and negative 3. So to solve this, I sandwich my absolute value in between 3 and negative 3. And by sandwich, I mean I put it in and drop the absolute value, and then I start solving. I would multiply both sides by 4. Sorry, it's disappearing. I multiply each piece by 4, remember, because I want to get rid of it. I have negative 12 is less than or equal to n is less than or equal to 12. So a closed circle on 12, a closed circle on negative 12, and I shade everything in between. This was an and. It wouldn't hurt to go through and label right away or and. If it's an or, it's going to be greater than, and it's going to be a compound or, meaning they go different directions, so they don't have to overlap. Number 3, I have the absolute value of x divided by 6 is greater than or equal to 5. That means on a number line, it either has to be more than 5 this way or more than 5 that way. So I'm looking for x is greater than or equal to 5, or x is less than or equal to negative 5. So x over 6 is less than or equal to negative 5, or x over 6 is greater than or equal to 5. I multiply by 6 on both sides. X is less than or equal to negative 30 on this one, and x is greater than or equal to positive 30. So closed circle on 30, shade this way. Closed circle on negative 30, shade this way. It will not always be the case that it ends up working out like you're seeing here, where it's the same number, just one on one side and one on the other. I really just want everyone to have the notes written down for this and see 2 examples, but we're going to spend a lot of time working on these ones in class.